start कर लेते हैं and I'm going to recap KB what we did last time. ठीक है, we had an extra class उसके अंदर we did titration. बल्कि दोनों let's do both very quickly again. Okay, you had कहाँ से we started with I told you that if you want to make a salt there are four ways. You want to make NaCl, so the acid would be HCl. And you've got four options. You've got a metal, sodium, you got sodium oxide, sodium hydroxide, or sodium carbonate. Okay, there are four equations. Metal के लिए you can't you can only use mazet metals. Uh, Aluminum nitrate है, so the acid would be nitric acid, and it's going to be aluminium oxide, aluminium hydroxide, or aluminium carbonate. Okay. And I told you there were two methods. One was excess, and the other one was titration. Excess was if the reactant was insoluble and the salt produced was soluble, so that would be excess method. Or titration was if all of them were soluble. Okay, group 1 compounds are all soluble, then you're going to use titration. Excess में क्या था? When you had excess method, for example, I wanted to produce MgCl2, so the acid was HCl and I used Mg metal, right? So the way we're going to do that is okay, we're going to put a lot of Mg into the acid so that all the acid gets used up and all of it gets converted into the salt. So in that way, your solution, all of the acid will get converted to your salt. The extra Mg that you have added can be removed, can be taken out, can be filtered out. So your solution now just contains pure salt. ठीक है, तो excess method में you have to ensure that all your acid gets used up, because the acid is a solution and your salt is also soluble, so it's also a solution. So the acid, if it remains at the end, it will contaminate your salt. You don't want that to happen. So which is why all the acid needs to be used up. So you add a lot of Mg to it. Okay, so excess method was that add Mg to dilute HCl. Keep adding Mg until it remains undissolved, no more H2 undissolved and is in excess. And filter out the excess Mg, and then you start crystallizing the rest, right? As a titration was when all of them were soluble. In titration, the trouble was that if you had HCl and you had NaOH, and you're mixing the two, then since all of them are soluble, if any one of them remains unreacted, you add too much of it, the salt that is produced would be contaminated by the excess. For example, over here, I'm adding too much NaOH to it. So there's going to be NaOH that would be left because I added too much of it, right? So your salt will not be pure. It will have some leftover NaOH into it. Vice versa, if there was more HCl added, there's going to be some leftover HCl that will be part of the salt and water that is produced. So what you need to do when everyone is soluble is you can't use excess method. You have to have, if you have 5 particles of HCl, you need to add exactly 5 particles of NaOH so that nothing, I mean, the only thing that's produced is the salt. Or how would you do that? You do it via titration, right? Which is that you take HCl and you take NaOH. And if there are 7 particles of HCl in the flask, you're going to count particles and add exactly the right amount. There's a tap over here, and you're going to use a tap on the burette. And you're going to add exactly the right amount, right? And since you can't see those particles, the way you're going to figure out the end point or the turn-off point, okay, this is known as the end point. You get this thing where you turn off the tap. The way you're going to find the end point is that that at the start you have HCl, so the solution is acidic. And as soon as you start adding NaOH and the last particle of HCl, all the HCl gets used up and gets converted to the salt and water, the pH would be 7. And if you still keep adding NaOH, extra NaOH is added, there's going to be some leftover NaOH then, and your solution would become basic. So your indicators would tell you the color change, and they would immediately tell you that you should stop now. So if methyl orange is red orange, that means there's still acid left. So you need to add more NaOH to it. But if you add too much NaOH to it, it will turn yellow. So immediately as it turns yellow, you stop. That's what titration is. The titration process was that you fill the burette with one reagent, pipette or add HCl into the conical flask. You add a few drops of the indicator, whatever indicator, that's your choice. There are three indicators. You start titration, add NOH from the top, drop by drop, and you stop titration when the color immediately changes. And you get rid of the indicator, then you add charcoal to remove or absorb the indicator. Or the other thing is that once you know what volumes are used, you note down the volumes used and repeat without indicator, and then you do crystallization at the end. Okay? So that is what titration is. Every time you're going to use titration, it's going to be used in exactly the same way. Okay? You have to write exactly the same things. So is this all clear? We'll practice more. We'll do past paper questions and we'll practice more. Okay? But is this clear?
Yes.
So now the next thing that we're going to do is it's the third method of preparation of salts, and that's ionic precipitation, or simply so you call it precipitation. That's your third method. So what happens in ionic precipitation is uh, this is for preparing insoluble salts. Okay, this is for preparing insoluble salts. And this is the only way of preparing insoluble salts. There are plenty of insoluble salts. And this one is relatively an easy method if you get it. You don't have to remember a lot of stuff. So any insoluble salt. So for example, I want to prepare barium sulfate, okay, which is an insoluble salt. So how do I know it's an insoluble salt? Was sulfates may go and have a look at the solubility table. So you would notice that sulfates, well, they're mostly soluble, except for barium sulfate. Barium sulfate is not soluble. So is strontium sulfate, silver sulfate, lead sulfate. These are not soluble. Okay? So barium sulfate is not soluble. So how do we prepare? How do we prepare barium sulfate? It is very straightforward. What you need to do, since it's an insoluble salt, which means it does not dissolve, you're going to think of two reagents. Reagents are chemicals, right? You're going to think of two of them. One of them must have barium in it, and the other one must have. Well, if I want to make barium sulfate, I need to have two reagents. One has barium, and the other one has sulfate in it. So, यहाँ पे लिख भी देता हूँ. You're going to think of two soluble reagents, but they have to be soluble. One should have, so one of them should have barium, and the other it should have sulfate in it. So one should have barium and the other one should have sulfate in it. But remember, barium ions are not going to be alone. There's going to be some negative ion that's going to be attached to it. ठीक है, a
The
positive ion.
nitrate.
हाँ, तो वो it could be anything. It could be barium nitrate. ठीक है, that's one option. So barium ions attached to nitrate ions. So formula क्या होगा? It's going to be BaNO3 twice, right? Any negative ion. It could be barium chloride. BaCl is -1, so again it's going to be BaCl2, right? As long as it is soluble, it could be barium hydroxide, Ba plus 2, OH -1, so that's BaOH2. Yeah, that's barium hydroxide. That is also soluble. Okay, if you look at the solubility table, so hydroxides, what it mentions about hydroxide is that group 1 is soluble, and those lower down in group 2, which includes barium hydroxide, that is also soluble. Or कौन सा negative ion है? Carbonates can't be carbonates, that's not soluble. According to the solubility table, this is not soluble. So barium carbonate is carbonates के बारे में कि they're not, most of them are not soluble. And so on. Barium phosphate, can't use barium phosphate as well. You can't use because carbonates and phosphates are they're mostly insoluble except for group 1. So the top 3 I can use. As the same goes for sulfate. I want either like the I'm looking for 2 soluble reagents. As the same goes for sulfate, there's probably going to be some positive ion attached to it. So without any sulfate that is soluble, what could be the positive ion? It,
Sulfuric acid H plus.
वो भी हो सकता है. It could be sodium sulfate. It could be sulfuric acid, which has H plus 1, so it's going to be H2SO4. A lot of sulfate. Remember, sulfates solubility is that all sulfates are soluble except for 4, 5 sulfates. So pretty much most of them are soluble. It could be magnesium sulfate. You get any sulfate that's soluble. But can't be silver sulfate because that was an exception that it wasn't soluble. Sulfates ka tha solubility table that all of them are soluble except for silver, lead, barium, and strontium, and partially calcium. So silver, don't use that, okay? So anyway, so you're gonna think of any 2 of them. So I'm gonna just rewrite them. I'm gonna pick one, and the reaction is pretty simple. The reaction is quite simple. What you're going to do is,
So what are we using?
मैं बताता हूँ. Either sin I'm just going to pick, let's say, barium nitrate. How do we know barium nitrate is soluble? Because NO3 minus 1, anything that has NO3 minus 1 is soluble. Or yes, I'm going to use sodium sulfate. ठीक है. So I'm gonna pick these 2. So I've got barium nitrate and I've got sodium sulfate. Okay, this is soluble. All nitrates are soluble. All group 1 compounds are soluble. The 2 are going to react. So they're not actually going to react. It's called precipitation. What happens is they're not really going to react. What actually happens is when something is soluble, it dissociates. So barium nitrate will dissociate. Its ions will get scattered in water. Or this is also soluble, so it also dissociates. So the solution will have a lot of barium ions and nitrate ions floating around. And so it will also have a lot of sodium ions and a lot of sulfate ions floating around. Okay. So all these ions, because they're soluble, they all mix up and they all float around. But the thing is, these ions would randomly combine with each other. So if the barium ions, they combine with sulfate ions, what then happens is, okay, they start forming a crystal because barium sulfate is not soluble. So if these 2 get together, so they start attracting each other very, very strongly and they start forming barium sulfate. Okay, these 2 barium ions and sulfate ions were not soluble. So one ion comes from one compound, the other ion comes from the other compound, and in the solution they get together. and they start forming crystals. This barium it joins with the sulfate and it also. So all these barium ions and sulfate ions, they're going to all get together and they'll start forming crystals. Four conquer. So they'll start forming crystals and they'll start forming a precipitate that will settle at the bottom. Okay, so all the barium ions and sulfate ions, they basically form a precipitate. Okay, is this clear? You can remember barium sulfate is not soluble. So if one of the compound goes into the solution, produces sulfate, the other one goes into the solution and produces barium ions. So the ions, they mix up and they get together in the solution and they join up and they start forming crystals. Or as a sodium and nitrate ions, they never get together because they're very, very soluble. That means they remain dissociated. मतलब उनके बीच में the attraction is probably not that strong. And since it's not a very strong attraction, uh, they just remain floating around. Okay? Soluble compounds were compounds that dissociated. The sodium nitrate group 1 compounds are all soluble. So they just, even if they get together because they're very soluble, they will dissociate again. The barium sulfate will form a precipitate. और फिर उसको क्या करना है? You just filter it out. ठीक है? Is this clear? Everybody clear? Yeah, is this Sarar? Nabila, is this clear?
Yes, sir.
So this is what happens when sodium sulfate and barium nitrate, they mix together. Or the description is pretty easy. Number one, as a description is, you mix sodium sulfate aqueous any amount with barium nitrate aqueous. ठीक है, what you're going to do is stir. Stir कर लो वैसे just to mix them. Stir and mix. A precipitate would immediately form. What you're going to do is filter out the precipitate of barium sulfate formed. That's it, bas. Barium sulfate formed क्या होता है? अच्छा, that's it. बस दोनों को mix किया, just mix them together and filter out the barium sulfate precipitate that's going to form. The last thing is, once you've filtered it, wash the precipitate with distilled water. Precipitate, remember, is a solid, ठीक है? Wash precipitate in distilled water and dry in sunlight. You can wash the precipitate because it's an insoluble precipitate. Yeah, that's it. So mix sodium sulfate with barium nitrate, stir and mix. Filter out the precipitate that's formed and wash the precipitate in distilled water and dry in sunlight. You don't need to crystallize it because it's already a solid. So I'm going to do some other questions about ionic precipitation, which is, so let's do a few more. Okay. Remember, insoluble salts are going to be produced. So if I want to produce insoluble salt, let's say copper carbonate. You can remember, how do I know copper carbonate is insoluble? Because if you go and have a look at the solubility table, it says, वो क्या कहता है carbonates के बारे में? It says that carbonates and phosphates are all insoluble, except for group 1. This is not group 1, so all of them are insoluble. So this is insoluble. How do I make copper carbonate? I want insoluble copper carbonate solid to be produced. And for that, I'm going to mix two reagents. One of the reagents would have copper ions, and the other one should have carbonate ions. Okay? But the two reagents, they have to be soluble.
Copper sulfate and sodium carbonate.
Okay? मतलब सल्फेट कर लो, all sulfates are soluble except for silver, lead, barium, and strontium, right? So sulfates, copper sulfate is soluble. Could have been copper nitrate as well. Could have been copper chloride as well. That will be soluble as well. अच्छा, और carbonate के साथ you need a positive ion. So group 1 compounds are all soluble. So let's make it sodium. आसान है, sodium is the easy one. So sodium carbonate, right? Both of them are soluble. When they go into water, when they are added, they will dissociate. Sodium carbonate is already soluble, so it's aqueous, it's dissociated, all the ions are scattered. Copper sulfate, again, all the ions are scattered. If they mix together, the copper ions and the carbonate ions, which are floating in water, they'll get together and they'll start forming a crystal of copper carbonate. Okay, that's what will happen. But the copper from the copper sulfate and the carbonate from sodium carbonate will get together. And the rest of the ions will remain floating around because they are soluble. Sodium and sulfate ions, group 1 compounds are all soluble. So those ions will remain dissociated or dissolved in the solution. They will not form a crystal. Okay. So sodium and sulfate, because group 1 compounds are highly soluble, they remain part of the solution. They don't form a crystal. Okay. While copper carbonate ends up forming a solid. और फिर description simple है कि you mix. So what is the description? You just mix एक second. नबीरा, यस, उसको न्यूट्रलाइजेशन भी कहते हैं, बल्कि न्यूट्रलाइजेशन पे ना मैं बाद में आता हूँ, ठीक है, कि व्हाट इज न्यूट्रलाइजेशन. But excess method is often known as neutralization as well. क्योंकि उसके अंदर ना आप एसिड को completely न्यूट्रलाइज करते हैं. अच्छा, एनीवेज, ये इसकी डिस्क्रिप्शन, यू मिक्स, the description is easy mix copper sulfate and sodium carbonate. Um, stir कर लो, ठीक है, there's no need for stirring, but let's write stir. Filter out the precipitate of copper carbonate that's formed. And what's next? What you do is you wash the precipitate with distilled water. And then what you do, you filter. And dry the residue. ठीक है, is this clear?
Yes, sir.
Yes, sir.
बल्कि इसको mix and stir कर लेते हैं. So here, that's the last one. That's ionic precipitation. So what we're going to do is, okay, we will. So what we'll try and do is that we will एक second. मैं वो खोलूँ notes वगैरह खोलूँ notes नहीं past papers. ठीक है, sending it in the WhatsApp group. ठीक है, specifically salt preparation. Just hold on 1 second. Salt preparation. Let me share the notes. Group किधर गया आप लोगों का?
So this is the fourth chapter, right?
Hmm?
Fourth chapter है ना ये?
हाँ, ठीक है. I'm attaching the marking scheme as well. अच्छा, इसमें just remember कि the solubility table. I mean, there's a lot to remember. ठीक है, but you have to somehow remember stuff. The ions, the list of acids, uh, the 4 or 5 equations. ठीक है, you have to know how to balance them. अच्छा, ये आगे एक second. Let me. Let me open this. I say mixed the O levels iGCSE. It's both mixed. I said, so remember, we'll just, you can see this on the screen, right? So हम इसमें ना we'll just do at the moment preparation of salts, which is 22. 1 second. Page 9. हाँ ठीक है, preparation of salts. So we'll just focus on preparation of salts. I say यहाँ पे, now remember it's, so over here, how to obtain pure dry crystals of calcium chloride. ठीक है, this is the salt that you want to prepare. अच्छा, खैर, the question is actually pretty simple. लेकिन let's do this question. बल्कि let's do the question first. अच्छा, in this question, the solution is already there. You already have an aqueous solution of calcium chloride. Well, you already have calcium chloride aqueous. All you need to do is you need to have pure dry crystals of calcium chloride. So in this one, you don't actually have to prepare the salt. You just have to do crystallization. You get crystallization. How would you do that? Okay, evaporate, heat and evaporate the solution. Till saturation point. And then what? Cool gradually.
Dry in sunlight.
To obtain पहले filter करो ना, obtain large crystals. So you filter out the crystals.
The
And
threshold का कोई idea है आपको? क्या
वही
होगा?
तो वही हाँ,
Chemistry
तुम लोगों का तो रिजल्ट है कल. मैं समझा तुम लोगों का नहीं है. ये पाकसी इस्लामिक को तो नहीं पता.
नहीं नहीं है, इंस्टेंस केमिस्ट्री का क्या होगा? वो दोस्त पूछ रहा था.
यार इसमें आया नहीं है अभी.
अभी तक तो नहीं आया. वैसे आपको कोई आइडिया है कितना होगा?
नहीं. मेरे ख्याल से हाई होगा थ्रेशोल्ड। ये पेपर इतना मुश्किल ही था। चलो यहाँ पे तुम लोगों का भी है ना रिजल्ट?
Yes.
तो मुझे पता ही नहीं था, मैंने कहा तुम लोग शायद बचे हुए, तुम लोगों का भी रिजल्ट है। वासी इस्लाम में था। चलो बेस्ट ऑफ लक उसके लिए। बाकी जो वापस आते हैं क्वेश्चन पे, मैं उसका पता करता हूँ, फिर मैं ग्रुप में शेयर कर देता हूँ अगर कोई मुझे इन्फॉर्मेशन मिलती है ना। अच्छा एनीवेज, मैं इसी क्वेश्चन पे ना, इफ ऑल्दो दिस क्वेश्चन इज नॉट अबाउट सॉल्ट प्रिपरेशन, इट्स मोर अबाउट just forming crystals, ठीक है? You have aqueous solution and you want crystals. If they had asked for preparing the salt from scratch, so without what acid would you use?
Hydrochloric acid.
ठीक है, तो it's obviously going to be HCl. And you're going to have four options, ठीक है? Calcium, calcium oxide, calcium hydroxide, calcium carbonate, ठीक है? So let's go with calcium carbonate. उसमें क्या होता है? Water and carbon dioxide is produced. Calcium metal can't be used. Metals, only mazit would be used. So this is a solid. All carbonates are insoluble except for acids are all soluble. Chlorides are all soluble except for silver and lead. So you're forming a soluble salt from an insoluble reactant. So method of preparation क्या होगा? That's going to be excess method. ठीक है, remember this one doesn't require this, but I'm just doing this anyways. What you're going to do is you're going to add excess of calcium carbonate. ठीक है, you're going to add a lot of calcium carbonate until all the acid is converted and it gets converted into calcium chloride. None of the acid is left. So keep adding calcium carbonate until you stop seeing bubbles of CO2 gas or calcium carbonate stops dissolving. That means all the HCl is gone. Well, the bubbles will stop forming. And once that happens, you filter out the calcium carbonate solid. So the only thing now left in the solution is calcium chloride. And you're going to form crystals out of it. Okay. So next one. Ionic equation. We're not doing ionic equation yet. As he's saying iron powder with sulfuric acid. How do you make iron 2 sulfate from it? So he pretty much iron 2 sulfate means Fe is +2, SO4 is -2, so the formula will be FeSO4. And he's now salt किससे बन रही होगी? It's obviously sulfuric acid, which is H2SO4. And he's saying that iron powder is used, so that's iron. That's a solid. Sulfuric acid is aqueous. Sulfates का क्या? All sulfates are soluble except for silver, lead, barium, and strontium. And plus metal plus acid will produce H2 gas. अच्छा, again, this is excess method. We need to excess ही है ना, क्योंकि the reactant is insoluble. So we need to convert all the, तो क्या करेंगे? Add
Fe in
excess
excess.
Fe to H2SO4 aqueous. How do we know it's an excess? Keep adding until you stop seeing bubbles of H2 gas. इसका मतलब all the H2SO4 is gone. If there is no H2SO4, there is no reaction. So keep adding Fe.
तेरे क्वेश्चन 2 मार्क का क्वेश्चन है तो बस सिर्फ मेथड नहीं बताना सिर्फ.
उसने क्या पूछा? Describe the essential practice to prepare pure dry crystals of हाँ, इस वाले का अगर 4 मार्क होता फिर, लेकिन जस्ट टू बी ऑन द सेफ साइड, लाइंस उसने दी हुई हैं. तो will until no more bubbles of H2 gas are seen, और असल में ना उसने एक्चुअली ज्यादातर मार्क्स जो है ना, वो ही ऑलरेडी टोल्ड यू. ही टोल्ड अस के वो एक्सेस है, तो वो वाला मार्क भी चला गया. ठीक है. ही टोल्ड अस द रिएक्शन एज वेल, सो दैट मार्क इज आल्सो गॉन. ठीक है. सो but यहाँ तक ना, दिस इज काइंड ऑफ irrelevant. He already told us that in the question. तो I guess start कहाँ से होगा? You filter out. Basically, this is where it's going to start, because the previous part has already mentioned that in the question itself. So you filter out excess Fe. And then you crystallize, evaporate the solution. Till saturation point or crystallization point. Cool gradually. Filter the crystals that are formed. You filter the crystals formed. And then what you do is dry crystals in sunlight. Okay, so I guess the answer would have been this part only. Okay, the previous part he's already mentioned it in the question. Is this clear?
Yes, sir.
Okay. So chalo, we'll continue with the same worksheet. Okay, we'll continue tomorrow. You've done all three methods. Ionic precipitation, remember, उसका ना एक chart भी बना लेंगे ionic precipitation. And वो करके ना we'll make a chart and I'm going to put everything. I'm going to send you a sheet where everything that needs to be remembered is going to be in one place. ठीक है. Or plus your notes, I'm going to send the notes as well. So we will just practice more questions, past paper questions tomorrow. ठीक है. चलिए, okay everyone. और जिन जिन का result है ना, ठीक है. Best of luck to you. ठीक है.
Okay, Allah Hafiz, sir.
Okay, take care.